So now we have another things in producer theory, production function. But in the case of consumer theory, we had what? We had utility function. Utility function. But here we have production function. The production function is a function that we map from the RL plus to the real number, to R plus. Why it's not strictly positive? Because when we write R plus, this R plus includes 0 as well. Because this kind of real number, it shows non-negative real number. That means still we have 0 here. Why we have 0? What do you think? When we are mapping our production function, we are mapping this function from RL plus to R plus. Why not R plus plus? Yeah, and other things? So it means here, when you are mapping, when we include 0, it means it's possible to produce nothing. For example, someday we decide to produce nothing. And especially in the long run, it's possible. Sometimes we just take a risk and produce nothing. That's why 0 is included in our production function. And we are mapping from RL plus to R. This function, which we called as a f of x, it shows our production function. If you remember, for the case of utility maximization, we used a notation of u for the utility maximization, and this u was a function of, for example, x and y. But in the utility maximization, this x, suppose this is also both of them as x. Was a function of x. Here, this x was serving as a role of service or goods or the consumption bundle. The difference between the utility function and the production function, in the production function, the element is consumption bundle. This is our consumption bundle. This x. But in the case of production function, this x is our input bundle. Our input bundle. And when we clarify more, this input bundle can be the level of labor, capital, natural resources, and other things. And when we are simplifying our production function, we mostly use just L and capital, L and K, or labor and capital, to make it easier to draw the curve, to maximize utility. Because when we have only 2 unknown, we need only 2 equations. By using like Lagrangian function, we move to 2 equations, 2 unknown, and we can solve for L and K. So if we have like more input in our production function, like we have labor, we have capital, we have natural resources, we have entrepreneurship, which is 4 input here, then it makes it difficult to solve for the different combination of our input. So also we have technological efficiency, which is, this is the definition. If we have a production plan of Z, which this Z is a vector of input and output, is technologically efficient if and only if there does not exist a production plan of z prime, which is, this is a vector of z prime and minus x prime and y prime. So it means, if we intuitively talk about the technologically efficient production plan is the highest production plan that you use to get the most. It means there is no other possibility to move forward to get better than that. So that's called the technologically efficient production plan. So now let's move to some example related to different types of production technology, which is one of the very common and famous production technology is the Cobb-Douglas. And the Cobb-Douglas production technology, the production function is takes this shape, which is f of x1, x2 is equal to x1 to the power of alpha, x2 to the power of beta. But the condition, which is alpha and beta, both of them is greater than 0. It means they should not be 0. So, and one of like the mostly common Cobb-Douglas function that we are using in production theory is this function, f of Lk is equal to L to the power of alpha, K to the power of beta, which is labor and capital. So it means x1 is labor and x2 is capital. They are just a matter of notation. And this one, Z capital, it shows the production possibility set of the Cobb-Douglas technology in case of 2 input and only 1 output. Here we have only 1 output, but 2 input. We are combining x1 and x2 to get y. So this x1 and x2 is our input and y is our output, such that the y, or the level of output, should be less than and equal to x to the power of alpha and x1 to the power of alpha, x2 to the power of beta. In this case, so we can write down y is less than and equal to L to the power of alpha, K to the power of beta. Just change x1 and x2 to L and K. And this one is our isoquant. Because here, this isoquant is a set of x1 and x2 and R2 plus. Why R2 plus? Because we have only 2 input. Such that the output, your y, is equal to x1 to the power of alpha and x2 to the power of beta. That means all the different combination of x1 and x2 that you are using to get exactly the same amount of output are y. And this is your input requirement set for the case of Cobb-Douglas production function, which is our y is less than and equal to this different combination. Is less than and equal to. So it means we are combining different bundle of x1 and x2 either to get more than y or at least equal to y. We are not talking less than y, because this y, for example, is your output, your optimal output. So these are the 4 different terms that we used for technology before, which is the input requirement set, isoquant, production possibility set, and production function. So this is number 1 is the production function. Number 2 is the production possibility set. Number 3 are our isoquant. And number 4 is our input requirement set. And also we have the same thing for the Leontief technology. As you see this Leontief technology, the format is similar to a kind of utility function. What kind of utility function is similar? So this one. This is Leontief production technology. And in the consumer theory, we had this one. Ux1, x2 is equal to mean of ax1, bx2. This kind of utility function we had, which was the perfect complement or substitute, which was the perfect complement. And here in production, we have Leontief technology, which is similar to this perfect complement. So again, in Leontief technology, it also means that these two input can be substituted. This two input is complement. This two input, as we had in perfect complement, that these two goods are complement, you cannot use each of them in isolation. You have to use both of them. For example, you cannot use a car without tire for driving to go somewhere, because the purpose of having a car is to use for transportation to go somewhere. When there's no tire for the car, so you cannot use that one. Here in Leontief technology is also that your input is perfect complement. It means you cannot produce only with having labor or only with having capital. You have to use both of them. So this is, again, the four things. This is the number one is your production function. The number two is our production possibility set. Number three, our isoquant. And number four is our input requirement set. Input requirement set. The same thing we can have for perfect substitute, which is similar to perfect substitute utility function. But in here, as you know already, for the case of utility, the perfect substitute was linear. There's also linear. Again, we have the production function, the production possibility set, the isoquant for this perfect substitute, and also the input requirement set.